So today we are going to learn beta angle problem related to the pentagonal lamina. Okay. So in this problem you see it a pentagonal lamina of dimension 25. So placed on one of its corners and HP. So we know that in a pentagonal problem also first two positions will be remain same. So that's why I drawn the two positions. You can see that pentagonal lamina of dimension so resting on HP with one of its corners. On the left hand side I have drawn the first position and then inclination to HP it is given 30 degree. So that I have drawn. Now we have to proceed with the beta angle because they have mentioned a word called perpendicular bisector. Okay, so for that first I will be drawing an angle line. Okay, so angle line I'm so 45 degree. So now we have to draw the perpendicular bisector, say from this corner point to exactly the middle point. Okay, this is M1. So first I will be taking a reference point of A, AM1. So this is focus of M. So this is the angle that is nothing but beta angle. So we have to find out this. So angle here we get it is around 55 degree. Okay, so now we have initially now from C to B, next D to E. So these two lengths will be same. Now we have to cut the reverse here, A to B. Okay, so this is B and this is E. Okay. Okay, now we will be extending this to get the final view. Okay. Okay, now this is A dash. So B dash we get this is, C dash will get this, and D dash we are going to get here, and E dash we will be getting here. Okay, now we have to join these points. Okay, so this is how we complete the beta angle in pentagon. Now we will solve the hexagonal problem on a beta angle. So first two positions are already drawn. Now we will proceed with the beta angle. You just see the question: a hexagonal lamina of dimension 25 rests on one of its own corners on HP. So we have drawn the first position. The lamina makes 45 degree to HP. So we have drawn the second position. You see it. Now you can see the question in they mentioned diagonal passing through the corner that is inclined to 30 degree to VP. So now we are going to show how the beta angle here. Okay, so before for that we'll be drawing a diagonal here. Okay, this is what the first diagonal, and this is our second diagonal. So I will be writing this FC1 and this is FC. Now I'm drawing, and first I'll take a reference point here, reference point. Okay, and now I'll be marking at an angle of 30. So that's what the inclination to 30 degree. Okay, so now I'll be taking a reference of okay, a reference here F I have taken. Now first arc, so this is what the first diagonal line we have to consider, this is what the second. So first we have to consider FC1. Okay, now with the beta angle concept, first this length we have to consider FC1. We are cutting the arc. Okay, so after cutting the arc, so to this point, exactly to this point we have to draw an locus. Okay, so this is locus of, this is C1, locus of C. Okay, after this the second arc length we have to cut, that is this one, FC. Okay, FC we have to measure and we have to cut on this locus line. This is your FC. Okay, now we have to join this FC line and then extend it. Okay, extend it to get the beta angle. So how much beta angle we will get it here? So we have to get so we are getting it around 44 or 45 degree. So it will be okay, no problem. We have this length. Now we have to transfer this diagram over here. We have the FC length. Okay, so first I'll be measuring this FE. So this FE length, okay, see this FE length is exactly equal to your FA. Okay, so we can cut two arcs here and here. Okay, two arcs. Similarly we have FD. This FD is exactly equal to this FE length. Sorry, CD and CB. So four arcs we cut it. Now the reverse, one arc length, it is exactly equal to C. FD, it is exactly equal to your FB. Similarly, so this FD, FB is exactly equal to FE and FA. So that means measuring one length, we can cut the four arcs. Okay, here this arc and this arc. So now this arc is not cutting. So this is FE. Okay, so now understood, right? The initial arc from FE is equal to FA, so that is exactly equal to CD and CB. Four arcs we have cut it. Then after that reverse we have cut it, that is FD exactly equal to FB. Similarly FB exactly equal to CE and CB. That's what we cut it. 1, 2, 3 and 4. So after cutting the arcs we have to name it. So this is E, this is D, this is A, this is B. So now we'll join this. Okay, so now we have to extend this. Yep. So A and A dash, so it is merging here. Okay, similarly we will see for B. So where the B is, so here we have the B. Okay, so initially we have marked for A dash, this is B dash. Similarly series C, this is C dash. Similarly we have D dash, F3,
That's why, madam, so that last madam also told like that. So some network problem is there. Have to come from the network place. So after that, I will for every class I will ask the students. So if you have any doubt, if there is any network issue, how to ask them.
okay. So now we will join it.
No, sir, clear. Okay. Yeah, madam. I already told you that today I will share with you. Okay. Okay, thank you.
So this is what the final position. So understood, right? So first diagonal length will be cut at FC1, then locus line, then FC. So we have to cut the arc, then connect, and then extend. You get the beta angle. Then transfer the diagram using arc method. Then the final position.